Have you ever wondered how scientists or data analysts decide if a new drug really works, or if a marketing campaign genuinely boosted sales? A test statistic is a crucial numerical value that helps us answer such questions, allowing us to evaluate a hypothesis about a population using data from a sample. It serves as a bridge, transforming observed sample data into a standardized score that quantifies the evidence against a null hypothesis. The core mechanism behind a test statistic lies in comparing observed sample results to what we would expect if a null hypothesis were true. Essentially, it measures how many standard errors our sample statistic is away from the hypothesized population parameter. This measurement provides a standardized way to determine if an observed effect is merely due to random chance or if it represents a statistically significant finding, giving it the authority to support or reject a claim. To understand how this works in practice, imagine you are comparing the average scores of two different teaching methods. You would first calculate the average score for each group and then use these averages to compute a test statistic, perhaps a t-statistic, which takes into account the variability within each group and the sample sizes. The larger the absolute value of the test statistic, the more evidence there is to suggest that the difference between the groups is not just a fluke, but a real effect of the teaching methods. An insightful detail is that different types of data and research questions requiring specific test statistics, each following a distinct probability distribution. For example, a chi-squared statistic is used for categorical data to assess associations, while an F statistic is often employed in analysis of variance, or a NOVA for comparing more than to group means. Understanding which test statistic to apply and its corresponding distribution is key to interpreting its p-value accurately, enabling rigorous statistical inference. Ultimately, a test statistic distills complex data into a single, interpretable number that gauges the strength of evidence for or against a claim. It empowers us to make data-driven decisions with confidence, providing a clear and objective framework for hypothesis testing in both scientific research and practical applications.